Okay, so in 13.5, like I said, all of this quiz, you need to be able to figure out what the amplitude is, given information, the midline, so on and so forth. The first thing that's important in this problem is the fact that we have a high tide of 7 feet and a low tide of 4 feet. This tide table is obviously going to be important. They wouldn't give it to you if it wasn't important. These A through B, you're not really answers these questions for you. We're just going to answer them on the bottom. Question says, what is the average depth of water at the pier? What is the, or D, that's going to stand for average? So average is not the A value, it's D, the midline. Middle, average is the midline for all problems of being for midline. And how do I find the average of something? Add them together. I have 7 and 4, so I have 7 plus 4. How many numbers are there? 2. So we have 7 plus 4 over 2, which is 11 over 2, or 5.5. So 5.5 should be your answer for the midline. Average is the key. And that's feet, by the way. Number 2, how can you find the amplitude of the variation from the average depth? The amplitude given the midline. Exactly. So really all the amplitude is the distance. So amplitude is the maximum minus the midline, or midline minus the minimum, but usually I like maximum better, it makes it pop. So amplitude is the max minus the midline. So what was the maximum tide? 7 feet. And then mine was 5.5 feet, so minus 5.5 feet, which is equal to 1.5 feet. Wow, that's 1. So these things aren't just written in words this time, instead of me saying, tell me what A is, tell me what D is, tell me what C is, so on and so forth. One cycle of the tide. What is the cycle length in hours? So how to find a cycle length? What is the one cycle? Kind of the period. It's how long it takes to get from the starting point back to the starting point again. So the length of one cycle is the time it takes for one complete pattern. So what you're looking for is, if we start at high tide, how long does it take to get back to high tide? So high tide to high tide. So how long does it? About 12 hours, yes. So that's going to be my cycle length. Number 4 says, how can you find a cosine? Models the relationship between the depth of water and the time of the day. So if I'm trying to write a cosine function, what do I need to know in order to plug that? The A value, the B value, C value. So I need to substitute A equals, what does A equal? 1.5, because that was my amplitude. B, we don't know yet, so we got to solve for that. C, is there a phase shift? Did it say anything about moving left or right? No, so C is going to be 0. And then what was the D value? So the only one we're missing right now is the B value. There are 2 formulas that we had that had B in it. We had C over B. We also had 2B, and usually that's the one we use. So 2 pi over B what is 2 pi over B a formula for? The period. And what did we say the period was? It was 12. So now I just have to solve for b to figure out what it is. So how would I solve for b? We would want to multiply by. So the b's cancel. I end up with 2 pi equals 12b. And then divide by 12. So b is equal to 2 pi over 12. Or how would I simplify 2 pi over 12?
Pi over 6.
Pi over 6. So now I have my b value over here. Now I just have to write my cosine function. So we have y equals, a always comes first, so it's 1.5, cosine, pi over 6, because that's my b, but b always has an x or a t or something behind it. Since we're talking for time, I'm going to put t there. We don't have a c value. Yes? No. It doesn't have to be. It would have to be if since we don't have a c value, you don't need a parentheses. A set of parentheses. So y equals 1.5 cosine pi over 6t, and then we have the last number in here. We have the d value, which is plus 5.5. So now I have my function. If you do not have a calculator, I strongly suggest, actually I don't strongly suggest, go get a calculator because you need it. Because in number 5 it says, how can you use a graph? And this graph would be a lot more complicated to do by hand and a lot more time consuming if we didn't use the calculator. A graph to find the times of day when the water depth is at least 5. Well, I'm kind of helping you through this, so I'm giving you the answers. We need to graph the function. So in y1, you're going to be typing in your 1.5 cosine pi over 6t plus 5.5. That's going to be in y1. We use x for t because we don't usually use the t. Then in y2, we're going to type in 5 because we're looking to see where it's at least 5. And then from there, we're going to find the intersection. Calculator. You need to make sure you're in radian mode, so if you haven't done that or checked that, you need to make sure you're in radians in order to do these problems. So mode, make sure you're in radian mode. Typing in 1 point cosine. I would suggest using parentheses for the pi over 6 part. I didn't already put a parentheses there, so I need another one. And plus. Pi over 6. What to do for a window. So my suggestion would be, so click window. Okay, so my window, how am I going on the X? Is that height? Is it time? What is it? What? And what do you think we would need to have for our time? What? 12 would be good if we were looking for one. I would suggest 24 so we could look for a full day period. So 24 would max X. And then I would go by ones. And then my minimum, I can stay 0. But what is my maximum Y value going to?
7.5.
7, because that's my height. Hit graph. And since I have y is equal to 5, that graphed that line for me. Because the original problem, if you go back and read this, that, where is it? It says, suppose your boat needs at least 5 feet of water to approach. So that means that I need to have a tide of at least 5 in order for me to go and be able to get to that pier. So when it's underneath here, I can't be there because then my boat's not going to be able to get there. So it has to be at these points or above. So what you're going to do after you have your window appropriate, you're going to go through and find your intersections. So remember how we got to the intersections? Second calc, so second base. And then we are looking for number 5, intersections. So I want you to go through. You're going to hit number 5, intersect. And you're going to find all the intersections. Now the first over here at 0. So I'm actually going to write that one down first. So on my paper, I'm writing from 0 to, and now I'm going to find that other intersection. So I'm over to the left so that it goes over to where it first intersects after 0. So this intersection is 3.65. So to 3.7 or so. Yes. Go through and find the other intersections. You didn't close your parentheses before 5.5. You also did close your parentheses before 5.5. Because you want to know 0 to 0. 0 to 7. 0 to 24 because we're looking for 24 hours. So you should have gone through and found some more intersections. So second trace, number 5. Go over find your next one. You should be hitting enter 3 times at each of those points. So we have about 8.4 to, now I have to find the next one over here. So second trace, number 5. Enter, enter, enter. 5. Then we need this last one right here. 20.4. And I actually don't like the 0, so I just want 3, so don't put 0, just put 3.7. Because if I look at my graph closer, I'm not actually touching the x-axis at 0. That was my fault. So, in that paragraph where we had one at 3.7, then we were completely above the line from 8.65, and then we had the one at 20.4. I don't understand where those numbers came from. Okay. So we found our intersections, and now number 6 is asking us over what domain should you graph the cosine function. We already said that, so what would be my domain? Domain or what values? x values. So what were my x values I put in my graph, in my window? I went from what to what?
From 0 to 7.
Which one is x? 0 to 24 because of what?
Full day.
Because I was looking for one full day. So since there 24 hours in a day. Between what times could come and go. Now we have to use numbers for that. We found our intersections, but about on the SLO, we need to bring it to context. We need to explain how it relates to the real world. Now we just have random numbers. So our starting time, our high tide, where we started at, was at 4 a.m. So I'm going to take and figure out what this number is in respect to that. So I have plus 3.7 is how much? So 4 a.m. What's 4? 7.7. So about 7:30. A little bit later than that. So 7:30 a.m. You can round. Now take your calculator and do 4 plus 8.4. That's about 12.4, so that's about 12:30 p.m. to then I have 15.65, so we plus 15.65, and most people do not do military time, so 19.95 minus 12 gives us about 7:30 p.m. And then for, obviously that's back about 24 hours again. So we're going to end up having, we're basically back to form again. So it kind of like repeats.
What did you increase by again? Was it 8.4?
By my intersection. So 4 plus 3.7 gave me 4 to 7:30. 8.4 to 15.65, that was 12:30 to 7. 20.4 plus 4, that's back at, your 4 o'clock again. You could say like 12:30 a.m. and then it's full circle. It's going back again. And obviously, the times that are low tide and 10 a.m. and 10 p.m., that's when you're not going to be able to come into the pier because then it's down around 4 feet and you need to be at least at 5 feet in order for you to come into the pier. So do not come around 10 a.m. or 10 p.m. because it's not going to work. But any of those other times will work. So that's how you get those times. So questions like this you're going to be able to have to do on the test or on the quiz. You'll be given information. You have to come up with the average. You have to come up with the amplitude. You have to come up with the symbol of it, so the period. Write your equation. Sometimes they give you the graph it and find the intersections. But this is the kind of stuff that we're working on. Okay, so I'm actually going to give you a